You may remember that your mole flower has one remaining petal on it, and that petal is going to be completed with the concept of molarity. If you look at the word molarity, you're going to notice that it has kind of that mole concept in it. So it's a concentration unit for solutions, and the higher the value of the molarity, the more solute that is present in the solution. So because you see that it has a mole factor in it, you're going to see that the molarity equation is going to be moles of solute over liters of solution. Okay, and often you're just going to see it as, again, that big capital M, and you're going to see it as moles per liter. And you may remember that molar mass is an italicized capital M, so this is a standard capital M for molarity. Okay, I'm going to go through a couple examples for you, and then you'll have some practice problems to do on your own. So, first question here is, how would you make a solution? You're given a volume here and a concentration and a formula. So most solutions are made from solids being dissolved in water. So what I need to really measure out is I need to figure out how many grams of this I need. So it's really a bridge problem starting with the volume. So how many grams you need depends on how much solution you're going. So it's a bridge problem starting with volume and ending with grams. So I need to get rid of milliliters since this is really moles per liter. So every time you see that big N, you need to think moles per liter. So I'm going to do 1,000 milliliters in 1 liter to cancel my milliliters. And then I'm going to use my 0.100 moles per liter to cancel my liters. To get from moles to grams, you should recognize that from your mole flower as molar mass. So I'm going to do 1 times 207.19. Again, that number is coming from the periodic table for lead. For nitrogen, I have to distribute that 2, so I'm going to have 2 times 14.01 for nitrogen. And then for oxygen, I also have to distribute, so I'm going to have 6 times 16 for my oxygen. And when I add all of those up, I'm going to get 331.21 grams. And that is my molar mass. Okay, when I calculate that, again, I multiply anything on the top, divide anything on the bottom, just like any other standard bridge problem, and I get 8.28 grams. Now, hopefully you're not writing as big as I am and you can squeeze this in. So in order to make the solution, I need to measure the mass. So I'm going to measure this out, measure my 8.28 grams of solid, and then dissolve the solid in water to make 250 milliliters of solution. And again, I abbreviate solution SOL apostrophe N a lot. Okay, if I'm going too fast, remember you can always pause the video to catch up with the writing. For example number 2, this time I'm giving you the mass of the solid and telling you how much water we use to make the 500 milliliters of solution. So this time I know mass and I know volume. So if you think about I'm trying to find molarity, I've got to end up with moles over liters. In order to do that, I'm actually going to start like I would a density problem. Since I'm looking for a ratio, the grams can very easily be converted to moles on the top, and then the volume is going to go on the bottom. And then it doesn't matter what I convert first, but I usually do the top first. I need grams to moles, so again, I need to do the molar mass. So again, if you can do this out to the edge of your paper, that would work. So I have aluminum, 2 times 26.98. Again, the 26.98 is coming from the periodic table. For sulfur, distribute the 3 to the sulfur, 3 times 32.06. And for the oxygen, I've got 12 times 16. Okay, I'm going to add all of these up. I get 342.14 grams. And then that's what goes in my problem for 1 mole, 342.14 grams. So my grams are going to cancel. So that takes care of my moles. They match up. I now have milliliters that I need to get to liters. So since milliliters are on the bottom, I need 1,000 milliliters on the top and 1 liter on the bottom. Okay, now I'm just ready to calculate. Again, multiply the top, divide on the bottom to get your answer. It'll be 3 sig figs. Again, this is a definition, so that doesn't count. All of your other numbers do count for sig figs. So this counts as 3, this would be 4, this would be 5, so least amount would be 3. So 0.0509 moles per liter would be your answer for that problem. Last type of problem is a little bit different than the rest of the molarity problems, but it is a type of problem that we do encounter when we do dilutions of solutions, and it's also very useful for things that are liquids to start with. So a lot of acids we buy as a solution, so you have to know how to dilute them. We buy them in a concentrated form, and you can always make them less concentrated. You can't make them more concentrated. So this is a very useful lab skill. So this problem, you have some different information given. So you'll see that you have a volume of 100 milliliters, a volume of 250 milliliters, and a molarity of 3.00 moles of sulfuric acid. So again, this is something, again, we would use in the lab situation with an acid that's a liquid. It doesn't start out as a solid. So kind of, if you remember back to gas laws, if you have 2 volumes, you kind of need to identify which one of them. So if you kind of look at all of this, these two are joined together. So the dilution equation follows, and it basically says that your concentration times your volume in your first scenario is equal to your concentration times your volume in the second scenario. So C is concentration, and this nice part about this equation, it can work for things other than molarity. It works for mass percent problems. So if we encounter them, a lot of times you see those things in biology type labs. So if you're taking AP Bio in the future, you may see that again. And then V is for volume. So since these two factors up here go together, I'm going to call this V1 and this M1 or C1. So those are my two factors that I'm going to have in the first half of my question. So I have a concentration of 3.00 molar, and again, I don't have to write out moles per liter. Whatever units I start with is what they kind of will end up with, so I'll get a molarity at the end. And I'm going to put the 250 milliliters. So our new concentration is what we're trying to find, so I want to know molarity, so that's going to be C2. Now for V2, you have to be careful of the wording here. So if you look at how this is worked, this is 100 milliliters added to the 250 milliliters. So I end up having to add these two together to get a final volume of 350 milliliters. So because I'm adding water to dilute, I have to add my volumes. And from here, it's just an algebra problem. I need to get C2 by itself. And again, this initial equation is all you'd have to set up. If you can do this algebra in your head or with your calculator, you wouldn't have to show the actual division steps. But it does help you see it if you want to follow the units along. So I just am going to calculate that, and I'm going to get 2.14 molar is my new concentration. So those are the 3 types of problems that you generally see with molarity. So at the bottom of your worksheet, you'll see there's some practice problems in the textbook. You can do them on the back of the sheet, or if you don't like flipping or you like lines, you can do it on notebook paper. and see the board for the due date for these.